number 5, what I had to do, because I couldn't go any further. I plugged in the information I was given, and I really couldn't go any further. So what I did was, I looked.
Have the division stuff.
I have these 2 equations, and I solved both of them for e to the negative k times 10. And since they're both equal to this, can't I use substitution? Because both of these equal this. Yeah. So I substituted in that, I cross-multiplied, and I solved. And you may have done it differently. You could have used substitution way up here.
The 39 minus TE.
It was just a little uglier if you did it up here. So number 5 I knew would be a complete challenge. But I was hoping we'd have...
Be divided like that, like 39 minus TE over 46 minus TE.
Well, I solved, because I saw that both of them had this exactly.
Okay.
I thought, if I can solve for these, then I can use substitution. Yes, Carter? Did I need to use logarithms? I didn't.
Alright, because I got that same answer and I didn't use any, so I wasn't sure.
I didn't either.
Alright, awesome.
Yes?
Do you always have to simplify?
On like a word problem? Yes. The last line would be the decimal approximation. Yes, ma'am.
I just have like one question for 3B. Like
3B.
How you would like find K without knowing like what the time is.
Okay, I used K from A. I used the K from part A because I was dealing with the same. I was dealing with the same cup of soup. Okay.
So with the fact that it's like in a different environment, wouldn't change how slowly?
That would just change the other parts of our equation, but it wouldn't change that constant.
Okay. So it just like shifts.
Because that constant goes with that cup of soup.
Okay. So it just like shifted over?
Yeah.
So it would go like down and to the right?
It might. We'd have to look at the equation.
Doesn't this look like it says
It's going to have lots of changes. But K will not change.
Whenever you have the same problem, K stays the same. Okay.
Okay. All right. Today we're going to learn about 2 different things. We're going to learn about logistic equations, which model some really interesting phenomena. If we think about how things grow, and some things grow exponentially, will they grow exponentially forever, or do they eventually max out? Usually they max out. If we think about exponential growth of, say, one of your problems talks about deer. Let's say we put stipulations on hunting season and we are no longer allowed to hunt does. Ever. What would happen to the population?
It would skyrocket.
It would skyrocket. Okay? Now, of course, there would be some kill-off because people run into them. My neighbor ran into 2 in 1 week. Doesn't that stink? Yeah. But, and eventually, they're going to max out their environment, aren't they? They're going to eat up most of their natural resources. And that's when they start eating your daylilies in your yard. Do they eat your daylilies?
Our flowers.
Yep.
Oh my gosh, yes they do.
It used to make me really, really, really mad, and then I just had to quit caring.
Yeah, like when we first moved here, we'd like, we're all like, oh my gosh, the deer.
Mhm.
Like we'd go like feed them like out in the yard and stuff. Like we would like be up next to the deer. Like we'd like throw corn
Yep.
into the yard, and then
Yep.
we'd go watch them.
I've had a standoff with deer in my backyard.
And now my dad's like, let's whip out the BB gun.
My dog
like, I don't
has
want those in
My
the
dad like barked at the dog.
All right, so even though the population may grow, eventually it levels off. So it may grow exponentially, but then it'll level off. And in some cases, a population might even decline. But we can represent part of this using a logistics equation. So some populations initially have rapid growth, and we've talked about the deer, followed by a declining rate of growth due to some conditions that inhibit growth. We can model this type of growth pattern using a logistics curve. So these are two models that we could use. One involves our newest favorite number, e, and the other looks more exponential, just basic, 1 plus a times b to the x. So what do these things represent? So P of t represents the population given with respect to time. M represents the maximum growth. What is the maximum number that this environment can handle? A is a constant, K is a constant, and T represents time. Okay, B would be our base constant, and X would represent time in this form. So let's look at some examples where we're given everything, and we're just asked to answer some questions about it.
Miss Wilby, would it matter which one we use? Which formula?
It depends on the information you're given, which one you would go with.
Okay.
So in problem number 1, it tells us everything we need to know, and it already gives us the equation that models this situation. It says, on a college campus of 5,000 students, one student returns from vacation with a contagious flu virus. The spread of the virus is modeled by this function. Now, M represents our maximum growth. Now, does it make sense that the maximum growth would be 5,000? Because how many students could actually catch the flu? 5,000. Now, they may not all have it at the same time, but this would represent the number that have caught the flu. Where Y represents the total number infected after T days. The college will cancel classes when 40% or more of the students are ill. So how many students are infected after 5 days? What would we do, guys?
Plug in 5.
Plug in 5. Okay? Pull out your calculators and plug in 5 and see what we get. Good. So we get 54.019, which would be 54 students.
Wait, what's the K? Oh, is that, oh, it's 0.8. It's not K.
Okay, so after the first 5 days, we went from 1 to 54. So, assuming nobody went and got the Tamiflu, and this continues, when will the college have to cancel classes? So we're going to cancel classes when we hit 40%, right? 40% is how many students? 2,000.
It's like a half-life except for it's a
Yeah.
4 times life.
Yeah. All right, so this is a little more difficult to solve algebraically, but it's not impossible by any means. Okay, what I would do if I were you guys, let's just think through this.
I'm going to get 5,091.
Did you put all of this in parentheses? Okay.
That makes sense.
If I were to take this denominator, because I'm trying to solve for t, and multiply it out here, do you see I could distribute the 2,000? But I don't have to. Instead of distributing the 2,000, when I multiply this over here, and I get this 1 plus 4,999 e to the negative 0.8t times the 2,000, I'm going to go ahead and divide by the 2,000. Because when I divide by the 2,000, it's just a lot nicer. I get, I get 5,000 divided by 2,000. Isn't that just 5 halves? Okay, so instead of distributing that, I want you to go ahead and multiply this out here and then divide by this constant. Now we can subtract the 1 from that nicely, and so we get 4,999 e to the negative 0.8 t equals 3 halves when we subtract the 1. And then we divide by this 4,998. So it puts it down here in the denominator, right? Puts it down here in the denominator when I divide 3 halves by this. So that makes 9,000 998 when I double that, right?
That is a small.
It is a very small number. Okay, guys, now what do I do? Natural log. So it's going to give me over here negative 0.8t, because the natural log of e is just 1, right? Is equal to the natural log. I'm going to switch colors here. Oops. I'm going to have to pick a color we can see over in the gray. Okay. So I'm going to say the natural log of 3 over 9998. And then I'm going to divide by the negative 0.8. So I'm going to divide by the negative 0.8. So what do we get the time is approximately? 10.1? 10.139? So what day would they close school? On the 11th day. On the 11th day, they would cancel classes. All right, you try. Problem 2. Yep, when you wake up on the 10th day, not enough people are sick.
Do you take the maximum when you're doing like equaling, trying to find out like how long it's gonna take? Do you multiply the maximum times the population, or do you divide it? Because in the one before, it was like 2,000, 5,000, and you got 5 halves. What I'm talking about.
You would divide the 1,000 by the 100.
Excuse me.
Why is it the 11 for B? For B on problem 1, why is it the 11?
Because during the 10th day, we would hit that number, but at the beginning of the 10th day, you wouldn't cancel class during the 10th day. So you could say on the 11th day was the first day they canceled class, or during the 10th day. You could do it either way. Oh, you divide the 1,000 by 500 on B. Is that what you're doing?
Yes, ma'am.
Okay.
Wait, why do you do that instead of dividing the 500 by 1,000? Like, how do you get the 1,000 off the top?
So for B, what I would do is I would say 500 is equal to 1,000 1 plus 9e to the negative point, I can't read.
1656.
Okay, so we would multiply by this, and so we'd get 500 times this stuff.
How come you do that instead of multiplying by like the reciprocal or something? Or can you not do that if you're trying to?
Because we got to get this out of the denominator.
Okay.
And then we would divide by the 500.
Okay. Okay. That makes sense. Thank you.
You're welcome.
Okay, what does this mean here?
That means that you got,
Imaginary number?
yeah.
Because during 10th day, I wouldn't cancel school during that. This is 10th. No, because you go to school.
You go for
You go for the first day, second day, third day, fourth day.
Yeah, you go for 10 days.
I mean, it's,
So after 10 days,
On the 11th day.
on the 11th day, there's no school. So after 10
After 10
days.
days, yeah, I guess.
I'm not sure how we got a negative there.
I put after.
Do you have your work written down? If you'll bring me your work, I can look at that.
This is a lot of work.
Okay, so now,
I mean, I haven't looked back over it, but I was just curious because I saw this yesterday. I probably made a mistake.
Right here. This should be 2. Because you multiply by this over here to get it out of the bottom. Look at the board. So you multiply by that on both sides to get it out of the bottom.
Okay.
So you have 500 times that equals 1,000. So then you end up having to divide by 500. So 1,000 divided by 500 is positive 2.
Okay.
It's like a
Is that
so after
right?
what is yours?
That my 2 equals?
Yeah, I put it in 7 months.
Miss Wilby, can you convert decimals to fractions on the graphing calculator?
Yeah. And
So
punch
how-
that in.
But it says that there's an error.
ln of the natural log of 1/9, close your parentheses,
Math. Where's
divide by
fry?
this.
Oh, so you don't, like, because, sorry, up here, didn't you, like, multiply those two to get that number? Like, I don't,
But you've already done that here. You've got your 1/9.
Where's fry?
oh, and then you divide.
And then you divide by that.
Okay, so that whole ln.
ln of 1/9,
And then
close your
Parentheses,
parentheses,
divide
divide by
by
the
that.
negative 0.16. Okay, did we get 177.29? So approximately 177 animals? Okay, on this one, did you get 13.27 months?
Did you say 14?
So I would say during the 13th or by the 14th. During the 13th month. Or you could say by the 14th month. Okay, for this one, did we get 26.53 months? Okay, if you got part B right and you didn't have a chance to make it to part C, if you got part B right, you know what you're doing. Because part C is just changing this 500 to 900. So if you can do this, even if you had had more time, I'm sure you could have done part C. So I would say during the 26th month. Yes, Carter?
For letter C, which you said it said 901 since it says exceed. Because I got 26.603.
Yeah.
I got T is greater than that.
Oh, okay.
I just used the inequality because it says exceeds 900.
Regular month.
Wait, it skips 80s.
Carter, what you did is not incorrect
Okay.
because obviously we only have whole animals.
Oh, it is 177.
It says the same
But
You were wrong. I did not say 176. So I don't know how.
all right. So if you got A and B, then you know what you're doing. Okay. Let's look at a couple different problems. Now, number 3 is like number 1 in your packet. My example 3. Now, this is not number 1 in your packet, but it's like number 1 in your packet. So these are extra notes. So if I told you we had an initial value of 8 and a limit to growth of 56, and it passes through the point 114, could you model this logistics function? So we're going to choose this version, and we're going to see if we can figure it all out.
Is it because like they give you a point? That's why it's down to them.
It's just a little easier than dealing with E too. What is my limit to growth? What is the maximum growth according to this problem?
40.
56. 56 is as large as we can get before we can't. Okay, so now we've got that filled in. Now we got to fill in A and we got to fill in B. So they tell us the initial value is 8. So that means the value of the function is 8 when time is what? 0. So what could I plug in for x? 0. And what could I plug in for y? 8.
So is B kind of like a constant?
Where'd you get 0 from?
It says the initial value is 8. And what would the, that's not what I meant to do. What would the time be at the initial value? This would have a time of 0. So this actually is modeled by the point 0, 8. So if I plug in 0 for x, I'm going to get out 8 for y. Okay, so what's b to the 0, guys? 1. Goes away. So 56 divided by what number is 8? 7. So what does A have to be? A is 6. Now we could cross multiply and solve this. But when we can look at things and figure them out, because we have good number sense, we should do that. Okay, so A is 6. So now we've got y equals 56. 1 plus 6. B to the x. Now we just have to figure out B. How do we do that? Plug in 1 and 14. So now we plug in 1. We plug in 14. And so I'd get 1 plus 6b. And I'm going to go ahead and do the 56 divided by the 14.
Ms. Folby, I'm still a little confused about the B to the O. How could you just assume that it would be like, that it's nothing? Just trying to get rid of it? Or?
B to anything to the 0 is what?
It's 1.
1. And when we multiply times 1, it never...
I know, but like, why would you like give it a B to the 0? Like,
Because
where's the 0 come from?
I can only solve when I'm down to one variable.
So
I was trying really hard to get it to where there was just one variable.
So we just like decided
Uh-huh.
that we were just going to
So we did this next because that would eliminate our B.
Okay.
Okay? So now now that we found A, we can actually solve for B. What is 56 divided by 14? 4. Okay, so this is 4. So if I subtract 1, I'm down to 3. And I divide by 6, and B is 1/2. So the function for the logistics curve that models this situation is y equals 56 over 1 plus 6 times 1/2 to the x. So that is similar to number 1 that you'll be doing tomorrow in class, or on the bus with me, or in the hall with your friends at Beta Club. Or on the airplane.
Or on the airplane.
Yeah.
I'm actually sick.
Oh, sorry. Gotcha. Okay, so we good? Okay. Next one. Very similar. Initial population of 24, a maximum of 120, and it passes through 330. So this is like number 3. Our example 4 is like number 3. So let's get started. What goes up here? 120. Okay, 1 plus A times B to the, okay, we're going to make it 0. And at 0, what is Y? 24. So 120 divided by 24 is equal to 1 plus A. 5 minus 1 is 4. Okay, does it make sense how we got 4? Great. Now we have the 120, we have the 4, now we have to deal with the point. So what do?
Plug it in.
Plug it in. So we get 30 equals 120. 1 plus 4, B to the 3rd. So we're going to move this over here, divide by that. So we get 1 plus 4B cubed equals 4. So B cubed equals 3/4. So B cubed root is what we'd have to take. Isn't that the same as the 1/3 power?
Yep.
So I'm going to go 1/3 power here, and you'll see why in just a second. Works out nicely for our equation, actually. Cubed root is the same as the 1/3 power, so we're going with that. So when we plug it in, give y'all a second to catch up. When we plug in the 120, and we plug in the 1 plus 4 3/4 to the 1/3 to the x, what happens when I raise a power to a power? Don't I just multiply? So 1/3 times x, isn't that just the same as x divided by 3? Whoa.
So Miss Willoughby, you wouldn't like add them all the things on the bottom up.
You can't,
Okay.
because this is raised to an exponent.
Like it wouldn't be like 5 times 3/4.
No, because this is multiplied.
Okay.
We can't do that addition first.
So that's as simple as it gets.
That's as simple as it gets. Yes, Adam. Okay. Now, what if I didn't give you any words at all? I just gave you a graph and asked you to find a logistics curve, because this is what it looks like. Does it look like exponential growth for a while? And then it slows down, and then it kind of maxes out? Did I give you exactly the same information I gave you on the last one? I did. I gave you the maximum, didn't I? What is the maximum? 40. I gave the initial value. What's the initial value? 4. And did I give you a point that it passes through? Yes. So it's really the exact same type problem. It's just given to you as a visual instead of in words. So we have y equals 40 over 1 plus a b to the 0 is 4. I can tell a has to be 9, right? So I get y equals 40, 1 plus 9 Thank you, Jack. Times b to the x. And then what do? Plug in 1 and 10. So 10 equals 40. 1 plus 9, b to the first. So 1 plus 9b equals 4. 9b equals 3. b equals 1/3. To my equation, 40 over 1 plus 9, 1/3 to the x. This is what we're about to do. I only need about 5 minutes, and that's all I got. So it works out really nicely. Okay. So the little half sheet has to do with solving these cool looking exponential equations that are in quadratic form. You see the whole little half sheet. All of them are kind of in this form. Does this look?
No, it's not.
Okay, good. No, it's not supposed to be. Does this look like it's in quadratic form? A squared, a linear, and a constant? Sort of. It looks like a combo between an exponential and a quadratic. So, yeah, it looks like a combo. So if we thought of this, if we let n represent e to the x, wouldn't this just be n squared minus 7n plus 12?
Yes, it would. Okay.
So do you see how this is actually in a quadratic form? So if we let n represent e to the x, do you see how this models that? And this would factor to n minus 3, n minus 4.
That makes sense. You're able to do that?
Okay, but what is n? N is really e to the x.
Is n really equal to e to the x?
So, I just use this as substitution. Okay? So we could say e to the x minus 3 equals 0, or e to the x minus 4 equals 0. So e to the x equals 3. So x equals natural log of 3. Good. Or e to the x equals 4. So x equals ln of 4.
So it can be either of those?
Yep. Both of those are solutions.
Wait, so are we gonna be doing this n thing, or?
You don't have to. If you can go straight from here to this line, that's actually what I do.
But using the n, that's like an actual thing, like that's.
You can, yes. It's called n substitution.
Can you
And
set it as any variable, or does that have to be?
You can assign it any, yeah, as long as you use it all the way through. All right. All right, let's do another one.
Oh no. Do one of the ones on the sheet.
Number one. Yeah, number one. Oh,
It's not E this time.
Oh, it's
2 to the x.
Okay, so this time if we're using n substitution, we let n represent 2 to the x.
Right.
So this would be n squared plus 4n minus 12 equals 0.
got that part.
So we get n plus 6, n minus 2, which is really 2 to the x plus 6, or 2 to the x minus 2.
What about the? I'm
Okay.
confused on the middle part.
So we set
To the x.
this equal to 0, or this equal to 0. So we get 2 to the x equals negative 6. Is that possible? No. That gives us an extraneous solution, doesn't it? That is not possible. What about this one? Is this possible?
has to be a negative.
We get x equals 1.
It has to be negative in the.
Okay, there's no way to raise a positive base to a power and get out a negative answer.
I'm thinking I'm still stuck on E. Okay, never mind. If it's E, it can be positive or negative.
Mm-mm. We can't raise E. E is a positive number.
Okay.
This will never equal a negative number. Never.
So, if like one of your factors was 2 to the x plus 2, it wouldn't work out.
Right? Right.
Okay.
Okay? Okay. The bell's going to catch me. I'm going to make like a 5-minute video on this. I actually have 6 examples. If you guys need to go to my YouTube in class tomorrow and watch that on your phone, I'll upload a 5-minute video just on this. That's it. That's all I'm going to spend. All of it is due Monday.
So none of it.